Okay class, now we continue the next video 5.1.2, which is L'Hopital rule for infinity divided by infinity. Okay, this one meaning that, let's say if you find the limit fx divided by gx, and then if you get infinity divided by infinity, so this one is undefined. What you have to do is you need to apply L'Hopital rule, which is differentiate f and differentiate g. And then if you get L, so the answer for limit fx divided by gx is equal to L. Okay, the second one, if you get limit f prime x divided by g prime x is equal to infinity or negative infinity, okay, plus infinity or negative infinity, so limit fx divided by gx is equal to positive infinity or negative infinity. Example 6, find limit x squared divided by e power of x, which is x approach to infinity. Okay, let us try to substitute the value. Okay, let us try to substitute the value. So, infinity square divided by e power of infinity. So, okay, remember the graph. Okay, this is e power of x. Okay, if x is infinity, so the graph become negative. So the graph ex is infinity. So you get infinity divided by infinity. So you need to use L'Hopital rule. So differentiate. Okay, so you get limit x approach to infinity 2x divided by e power of x, and then you substitute the value of infinity, so 2 infinity divided by e power of infinity, so you still get infinity divided by infinity. So what you have to do is you differentiate second time. Okay, so limit 2 divided by e power of x. Okay, so here I can say that differentiate again. Differentiate again. Okay, so you apply infinity, so you get 2 over e power of infinity. So 2 divided by infinity, you get 0. So the answer is 0. Okay, next example 7. Okay, find limit x approach to infinity ln x square divided by x. So ln infinity square divided by infinity. So you get infinity divided by infinity. So if you want to know ln infinity is whether infinity or not, right? So you remember the graph. The graph of ln x is like this. So if x is approach to infinity, so ln x approach to infinity. Okay, so ln infinity approach to infinity. So now we differentiate ln x square. So limit x to infinity, differentiate ln x square with respect to dx, and then differentiate x with respect to x. Okay, so you can directly differentiate. So limit x approach to infinity, so you have 2 here, and then ln x. Okay, remember you have 2 minus 1. Okay, and then multiply, you differentiate this, you get 1 over x. Okay, and then you divide by, differentiate x, you get 1. So here you get limit x approach to infinity. So 2 over x ln x divided by 1. So you substitute the infinity. So you still get infinity divided by infinity. So what you have to do, you need to differentiate again. So differentiate again this one. So you have limit x approach to infinity 2 ln x divided by x, right? So you differentiate again, limit x approach to infinity, okay, differentiate 2 ln x with respect to x, and then differentiate x with respect to x. So you will get 1 over x divided by 1. Okay, so 2 over x. Okay, don't forget limit here. Okay, equal to limit x approach to infinity 2 over x. So now you substitute the value. Okay, I write again, limit x approach to infinity 2 over x. So you substitute the value of infinity, so 2 over infinity, you get 0.